Hello everyone. So today we are going to continue working on the IK solver for this deer character. So this is what I am trying to do here. So if there is some object under the toe of the character, deer character, using the IK system, it will automatically adjust the foot, the toe location by lifting the leg like this to compensate for that difference. So yeah, like this. So that happens on all four legs like this. So yeah, this is what I'm going to work on today. And this episode is sponsored by this generous patron. Thank you very much for your support. Alright, so now this deer character, we have implemented a way to lift each leg to align it with the ground. Actually, it doesn't align with the ground. We only have a way to lift each leg. For example, if I go here and set the lift percentage, if I increase it, you can see this element 0 is the left hand. It's at 0. It is like this, and as I increase, the character can lift the leg. But if it exceed 1, it will have problems. Yeah, so we should make sure it doesn't exceed 1. It should stay between 0 and 1, right? And have done the similar thing for the right leg. Let's test. Okay, it has a problem. See, it does bend, but in here it goes in a weird way. I'm not sure why, so we need to fix that issue. I didn't notice that last time. Let's see if we have such issues in other legs too. Yeah, that's fine. It's normal. Element 3, where's the element 2? Right, that is also fine. Okay, now let's troubleshoot and see what's wrong with the right hand, this one. Okay, so I did a little bit of debugging and found out the issue is that this value in the element 1 should be positive. And now when I test this, you can see it's lifting properly. Cool. Okay, so now that we have completed that part, we can focus on how to dynamically adjust those values, this lift percentage basically. Alright, so now let's open our deanimation script, and to test this, I'll add a box under this leg that only affect that leg, like this. So what I'm trying to do is I'm trying to find a way to lift only the only this hand to adjust with the box. At the moment, as you can see here, the hand is inside the box. Okay, now you can see I have already created a variable called lift length for each bone to calculate the amount that we have lifted the hand, the leg, through the IK solving system. So how can we calculate that? Right here, let's create a temporary variable that 3 what's the name I have given to the toe? Okay, toe. Actually we don't need the whole vector, we only need the z component. So float toe location equals leg dot toe no, not like this, should be like this. Here float toe location. Right, now toe location equals leg, sorry, only the leg dot toe dot on dot transform dot position dot y. Yeah, only the y value we need here, right? And then now we, after doing this, if I'm understanding this correctly, after doing these changes, the leg would be lifted, then I should get a different toe location. So leg dot lift length equals this one minus toe location. So that is referring to the previous location of the toe. Right, let's see if that works. If I increase this to 1, yeah, it is working. Good. So what's next? Okay, same thing should work for other legs as well. Yeah, we can see the lift length. Okay, so now let's do a recast downwards at the leg toe location to determine the actual hit point, and then we can get the difference of that hit point and the toes point. Then we can calculate the lift length we want to have in order to align the toe with the ground. Right, so how to do that? Right here we need to do a physics recast. I'll define recast hit to cast and then for each leg if we need to have the same method we used here. Right, now as this one represents the starting position, so start should be we can simplify this if I define those things in outside, but that will make the code longer. So leg dot toe dot postpone dot transform dot position. Oh, that becomes complicated, so I'll define another vector 3 let's call it R start. Oh, sorry, R start, and we can't have the leg here, so I'll just define the variable here and set R start here like this. And also we need to add vector 3 up, because we should start from an upper point compared to the toe, a higher point above the toe, and the direction is vector 3 down. Oh, we need a hit object as well, so this should be toe hit. Right, we don't need this part, only one is enough. Okay, now this do a recast hit downwards, starting from a point above the toe. Let's see if this works. If it is working, we should be able to see a line from the toe point. Have we seen that? Sorry, we need to do this draw line as well. Yeah. Debug draw line. Starting point is R start, end point is dot hit dot point, I guess. Yeah, point. Can we change color? Yeah. Right now we're seeing red lines at the top point. Oh wait, the red line location is not changing. See, it stays in the same way, same location. Alright, I know what the issue is. The issue is we should do the recasting after applying this change in boards. Now let's see. Yeah, now you can see the recast location is being changed. But I think this vector 3 up, this height is too much. So instead of vector 3 down, let's multiply this by 0.4. Yeah. Well, where's the hit point? Is it the hit point? The end of this recast should be above on this box, on the top of this box, as expected. Yeah. Then what? Then we need to figure out. So still I am manually changing the lifting percentage like this. So we need the character to automatically adjust it to place on the box. So how to do that? Right, let's try something like this. Now we have this hit point here. We can do something like this. We already have the toe location. Yeah, then if toe location, no wait, toe location 1, toe location, now let's call it not 1, after ik location before ik. Okay. Right, now we need to get the toe location after ik2. So I can just do it like this. Equals simply this one, this value. And then I can compare that to location after IK is larger than what? To hit dot point dot y. Then I need to increase the lift percentage. So leg dot lift percentage plus equals, let's say 0.01 f, else this should be decreased. We need to clamp this value between 0 and 1, but let's get into that part later. So let's take a look at again what we are doing here. If toe location is higher, then we need to, oh sorry, this should be reverted. If toe hit is higher, we need to increase. Right, now let's see if I stop and play again. Okay, something is wrong, but we can see this front leg has been properly adjusted. So what's wrong with the back leg? What's happening with the back leg? Let's see. I think they are colliding with, let me go to the scene view. What are they colliding with? The body of this mesh? I'm not sure. Are they colliding with the mesh itself? What if I change the deer character layer to ignore Recast? Oh, cancel. Only the mesh. Yes, change children. Still no. Right, let's try clamping. Oh. Minimum value is 0, maximum value is 1. Okay, let's do the same. Yes, well, and except this should be minus. And play. Wait, nothing is happening. Why? Let's see if the lift percentage is changing in the right leg. No. Sorry, this should be 0.01. Alright, now it is working. So if I go out here, you can see it. It is removed, and if I move right here, yeah, that's working actually. Not perfect, but we have something. See? Okay. Alright, so it's hard to test with the character itself. So let's move this one around. We can't. Right, it is working. What about this leg? It is colliding with the character. Right. Let's make this smaller, like 0.3. Okay, cool. We have some correction here, so it should be actually, we need to compensate for this difference. Also we need to prevent this shaking effect, but that's the details. We are making progress. So alright, so how to compensate for this difference? So for that, actually let's add some offset to this. Let's call it toe offset, but for now let's just go with the hard coded value 0.05 f. No, why don't we define a variable for that? In the data structure we have defined as the leg right here, and the leg public float offset. I'll add a default value for that, 0.05. Right, now here I can change this to offset. What if I make it 0.8? 0.1, 0.5, sorry, I didn't use it here. Still, plus leg dot to offset. Right, now you can see as I increase or decrease to offset, it is affecting. So 0.1 seems reasonable. How about 0.9 or 8, 0. I think 0.07 is good. So I'll set that as the default value. Okay, so shall we see the final version that we have worked on? Wait, let's make the size 0.3, 0.3. Okay, now when I move it, you can see leg is lifting. See, cool. Alright, so let's stop at this point for today. So yeah, actually this I need to disable this effect when the character is moving, otherwise there will be weird issues like this. See, you can see he's kind of dragging on the ground, which is not desirable. So we need to enable that adjusting system, I think only when the character is standing on the ground. So yeah, and let's continue to work on that from the next episode onwards. So thanks for watching. So if you like to support my work, you can get the membership of the Patreon club. Link would be in the description below, and see you in another episode. Goodbye.